This video continues the discussion of transformations. Now, the fifth type of transformation is a reflection across the x-axis. And in order to do this, we need to multiply the function by -1. Another name for this is shifting the graph upside down. So let's look at our basic graph of y equals x squared. And in order to reflect this graph across the x-axis, we need to multiply it by -1. So therefore, the graph or the function would be negative x squared. The graph of x squared looks like this. And if we take it and flip it over or reflect it across the x-axis, the new graph would go upside down. So this first graph is a graph of y equals x squared, and this graph in orange is a graph of y equals negative x squared. This is a reflection across the x-axis. Here's the x-axis. Notice that we have a mirror image on both sides. Now the next type of reflection, I'll label it number 6, is reflection across the y-axis. To shift a graph across the y-axis, we make the x variable negative. So if we have our basic graph of, let's change it up a little bit here, y equals the square root of x, and we wanted to reflect it across the y-axis, the new graph and function would have a negative where the x is. So you take x and you put a negative with it. Now I'm going to go to the calculator and I'll graph these in the calculator for this example. So I'll press a y equals key. I'll clear out my other functions that I had in from another problem. And then the first basic graph is the square root of x. Okay, so you enter that in. And the other graph is the square root of x with a negative x underneath the radical. Okay, so when you get those entered in, I'm going to hit zoom, number 6. Alright, now the first graph that it drew is our basic graph. It's going to the right, and it started at the origin. Now the other graph is the one that's reflected, and that's on the left side. So notice how the y-axis has a graph on the right and the same graph on the left. So that is our reflection from left to right. Now the last type of transformation is a vertical shrink and a vertical stretch. For both of these, we multiply by a constant. Now, a vertical shrink will occur when the constant, I'll call it A, is between 0 and 1. We're looking at the absolute value of the constant. And a vertical shrink will make the graph wider. Now, the vertical stretch will have a constant with the absolute value of it greater than 1. And the vertical stretch makes a graph more narrow. Now let's take a look at a couple examples of this. First example has a basic graph of y equals x squared, and we want to stretch this by a factor of 3. So what we would do in order to get the function, we would take 3 and multiply it by x squared. It's a stretch, notice, because the constant is greater than 1. Now I'm going to bring up the calculator and I'll show you how to graph both of those. First, clear out your functions. Okay, the first one is x squared, and the other function is 3x squared. I'm going to hit graph. Okay, now this is our basic graph, and then the other one, notice that it's a little bit skinnier, a little more narrow, is the one that is stretched. Okay, now let's look at an example for the vertical shrink. Let's look at the same basic graph of y equals x squared, and this time we want to shrink this graph by a factor of 1/3. So the equation would be y equals 1/3 times x squared. We multiply 1/3 by our basic graph. And the shrink should make it wider. So let's go verify this in the calculator. Okay, now y1 is x squared, so I'll leave that. I'm going to clear out the second function and type in 1/3 x squared. Okay, and then I'll hit graph. The first graph is our basic function, and then the other graph, you see it's wider. That is our 1/3 x squared.